All right, let's solve this example 2, which is also a separable differential equation. So that we have the differential equation, which is y times y prime plus 1 plus y squared times sine x equals 0, with the initial condition y of 0 equals 1. So we're going to use the same 4 steps that we have used in the previous example in solving this differential equation. Let's see how do we do that. So the step 1 is to write down the differential equation in the standard form, which is going to be y prime equals 1 plus y squared times sine x with a negative sign and divided by y. Now the next step is to separate the variables. So to do that, what I'm going to do, I'm going to keep all the y's on my left hand side and all the x on the other side. And before I do that, I am going to replace my y prime by the following, which would be dy over dx. Now, if I bring all the y's on the left hand side and I take all the x on the other side, my differential equation will be something like this. So I'm going to have y over 1 plus y squared dy on the one side. On the other side, I am going to have the following, which is negative sine x dx. Now this is nicely separated. Now the next step is to integrate. So if I integrate this, that is my step 3, then you see that I'm going to have the integral of y over 1 plus y squared dy equals negative integral of sine x dx. And if I integrate this, then I am going to have the following, which is 1/2 ln of 1 plus y squared equals cosine x plus c. How did I get this right here? Just in case if you're wondering, how did I get this here? This is using a substitution method, which is u equals 1 plus y squared, then du would be 2y dy, and that's going to integration like that on this side. All right. Now, if there is no initial condition, we are pretty much done. We have the solution right there, but now we have an initial condition. So therefore, we need to figure this. We need to figure out what this is going to be, right? Let's do that. To do that, I'm going to apply the initial condition. And if you remember the initial condition is y of 0 equals 1. So let's plug this back in. So if I plug it back in, y of 0 equals 1 right here, which implies 1/2 ln of 1 plus, now y is equal to 1, that is going to be equal to cosine and x is 0 plus c. Now I have an equation that I can solve for c. So therefore, if I simplify this further, this tells me that my c would be 1/2 ln of 2 minus 1. That's how we figure out the c value. Now I'm going to plug this back into my solution. If I plug this back into my solution, then my solution is going to be 1/2 ln of 1 plus y squared equals cosine x plus 1/2 ln of 2 minus 1. And that's how we solve these example number 2.